Okay, so we've most recently been talking about surface area. And what I want to do right now is actually do some nice highlighting and just try to understand the difference between surface area and volume, okay? So the surface area of a three-dimensional object is the area of the space, the region covering the surface, right? So we've been talking a lot about wrapping, right? If we're going to wrap this box with wrapping paper, how much wrapping paper do we need? If we're going to paint the outside of the box, how much paint do we need, right? And then we looked at nets. I've got some pictures of those below, right? If you could open it up and flatten it, the area of the flat net would be the surface area. So now we're going to start talking about volume. Volume is measured in cubic units, and you're going to want to highlight this, right? So that's, for example, centimeters cubed, inches cubed, right? And if you build a structure with blocks that are each 1 cubic unit, which we're going to do in a second, then the volume of the block structure is equal to the number of blocks in the structure. For example, if it's made from 8 blocks, it has a volume of 8 cubic units. If the blocks have an edge length of 1 centimeter, the structure's volume is 8 cubic centimeters. Okay, so in the second piece, once you've watched the video, you're going to be doing some stuff with blocks. And one of the things that's different is when we're thinking about volume, we're thinking about how much stuff fits inside, okay? How much stuff fits inside. So before, in surface area, we were trying to understand how much does it take to wrap the surface. Now we're trying to understand how much fits inside. That's the big difference, okay? So for example, if we took a single block, right, we're going to be playing with the pink blocks and the blue blocks. We've played with them before, and we specifically only looked at the surface, right? We only looked at it 2D. Now we're going to actually look at them in 3D. So if we looked at a single block, let's imagine that it is, it has a side length of 1 centimeter. Well, we know that the surface area of a cube is 6s squared, right? We've seen that before. Well, if s is 1, then the surface area of a single block where the side length is 1 is 6 times 1 times 1, which is just 6 square centimeters or 6 square units, right? So, I'm sorry. I think it said above that they were each 1 centimeter, right? Right, if they each have an edge of 1 centimeter. Now we're going to say, let's imagine that it's 2 centimeters. How does that change? Say we've got a cube and the edge lengths are 2 centimeters. Well, we can use the same formula for a cube, right? 6s squared. But this time, we're putting in, yep, you guessed it, 2 instead of s, and that's going to be 6 times 4, which is 24 square centimeters, okay? Now, what if we look at the second picture here? What is its volume in cubic units? Well, if they're each 1, it has a volume of 2 square units, right? Because we defined it as 1 block is 1 square unit. Now let's look at that rectangular prism, and that looks like the butter example, right, where we saw that 4 of the sides are the same. So what is the surface area of the rectangular prism that has a volume of 2 units squared? I'm sorry. Oh my. Big mistake. Big mistake. Who found the mistake? Oh, yeah. Big mistake. It's units cubed, okay? We're going to be super vigilant about that. It has a volume of 2 units cubed, okay? So what is that surface area? Well, the sides, look at those sides. Those sides are each a 1 by 1 square, right? And there are 2 of them. So that's going to be to square units, and that's surface area. So we use square units. And then we have 4 identical sides, right? The front, the top, the back, the bottom. And those are actually 2 times 1, right? Because it's the length is 2 and the width is 1. And we have 4 identical sides like that. So that's going to be 2 units squared plus 8 units squared. So all of a sudden, this rectangular prism with a volume of 2 cubic units has an area of 10 cubic units, 10 square units, has a surface area of 10 square units, okay? Now, that's what we're going to keep doing in all of these block structures. So now this, because it has 3 blocks, we're going to say it's 3 square units, 3 cubic units for its volume. And I'm going to start separating by using a V for volume and an SA for surface area. Now this has the same 2 on the side, right? That's 1 by 1 times 2, right? And then we have to add 4, just like the butter, 4 identical sides that are each 3 times 1. So that is 2 plus 12. So that is 14 square units covering those 3 cubes. Now, if we move over here, this guy actually has the same volume. We've just physically moved the cubes, but it still has 1, 2, 3 cubes. So it has the same volume, okay? Now, what about the surface area? That's going to be interesting. So we've actually got the back and the side that have the same area, 2 times 1 times 2, because that first 2 says there are 2 identical back and side. And the 1 times 2 is the length of the is the dimensions. And then in the front we see we have 1 and 1, right? And on the side there we're also going to have 1 and 1. That's going to be 1, 2, 3, 4 visible, right? So far we're at 4 plus 4, and we haven't done the top and the bottom. And if you look at the top and the bottom, it's pretty clear that the area is 1, 2, 3. And then on the bottom, the same thing, 1, 2, 3. So we actually have 8 plus 6, which is 14 square units. So even though we moved something, we actually haven't changed the surface area. Okay, let's make it more complicated. Now, here, if we look at these block structures, it's very clear that we have actually changed some stuff around. And as soon as we really change these things around, we're going to see that the surface area is constantly changing. Now, remember that the number of blocks tells us how many cubic units of volume we have. So these are all 4 blocks, 4 cubic units of volume, okay? Now, this one, same as the butter, the one on the left, we have 2 identical sides that are 1 by 1, and then we have 4 identical sides, but they're not 1 by 3 or 1 by 2, they're actually 1 by 4. So that's 2 plus 16, so that's 18 square units, okay? And that's the surface area of that rectangular prism. Now notice that this rectangular prism is actually quite different, okay? We got a top and a bottom. It's not like the butter. It's actually like the one with the red bottom that we see in class often. It has a top and a bottom square that are identical. So there's 2 of them. But the top and bottom square are 2 by 2. Look at that, 2 times 2. So that's actually 8. Now we have 4 identical sides also, but those identical sides are 2 times 1. So it's 4 times 2 times 1. So all of a sudden we're at 8 plus 8, and we're at 16 square units. Okay? So now let's take a look at these guys. And let's remind ourselves that the volume, as long as we're using 4 cubes, and we have to have a 4th cube back there because otherwise that top one would fall down. We're allowed to assume that it's there if we couldn't have it without it. So that's volume of 4 cubic units. But the surface area is actually quite tricky of these, and you're not going to be expected to do these all the time by yourselves. This is same front and back, 1, 2, 3, 4, right? So the front and back is 2 times 4, okay? Bottom is 3, right? And the top is actually 1, 2, 3. So that's 2 times 3, because if we look at the physical space, and then the sides, I'm sorry, let's turn that into a plus. And the sides, if we look at the sides, we got 1, 2, 1, 2. So on the sides, we actually have 2 times 2 square units. So we've got 8 plus 6 plus 4, and that's also 18 square units, just like that long skinny one. Now this one's super interesting here on the left. And I just want to create some space to do this. Okay, so the back and the side here are going to have an area of 3 square units. Okay, and we're going to multiply that by 2 because it's the back and the side. Now let's take a look at the front. We got 1, 2, 3 visible from the front, and also 1, 2, 3 visible from the other side. So that's actually another 2 sides that are 3 units squared. So now all we have to think about is the top and the bottom. Well, here's the interesting thing. Look at the tops, 1, 2, 3. And look at the bottoms, 1, 2, 3. So even though this isn't a cube, it's got all of its sides actually have the same surface area, which is super interesting. So we've got to add these 3 6s together, and we will still get 18 square units. Now, long story short, do they all have the same volume? Yes. They all use the same number of cubes, right? And the volume is constant. Moving the cubes doesn't change, right? It doesn't change how much you could fit inside. Now, the difference is they don't all have the same surface area, right? If we take a quick look, B has the least, and everything else has the most. And by the way, if I made a mistake and you guys point it out, I'll be very impressed. But I do have an answer key here somewhere. B has the least, and everything else has the most. So what happens is, essentially, if we distribute volume differently, right, we can change the surface area. Right? And we did something very, very, very similar with area and perimeter, where we saw that if we stretched the same 12 cubes into a long, skinny row, we would increase the perimeter, right? And it's very similar with surface area. Okay, so we have time for just one more problem, which is, we're going to just take a quick look. There's 4 of these. I'm going to leave you the other 3 to do if you want to. But in terms of determining the volume of each block structure, just think about how many cubes there are, and that will help you determine the volume. Okay, so you guys can do one by yourself. This has 3 in each column, and there are 1, 2, 3, 4, 5. Careful, that one's the same, 6 columns. So that's 3 times 6 equals 18 cubic units. Okay, this one's 4 is also easy. I'm going to leave that for you. Take a cool look at this one, number 3. There's a way to do it with adding and subtracting, but I actually think the easiest way is to ask yourself, how many columns of 3 are there? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's actually 10 times 3, or 30 cubic units. And again, we're assuming that there aren't cubes that we can't see, and we're assuming that any cube that's sitting there has something to hold it up because of the laws of gravity. So what you're going to do right now is actually work with some cubes. I'm going to give you cubes, and you're going to make rectangular prisms, and you're going to make, well, they call them block structures, but you're going to make rectangular prisms, and some that are not even, and you're going to write some stuff down. When it says write an expression for the volume of the prism with height h, they're just saying use h for the height where you don't necessarily know what it is. If you don't know what on earth that is talking about, you should feel free to skip